All right, and good morning. I hope everyone enjoyed the break. Today is September 8th. The quiz was on Sunday. I hope everyone got the quiz taken, and I hope that everyone participated in the discussions and all of that. If anybody has any questions about that, please let me know. Keep in mind also that I have updated all of the attendance. Obviously, we just had our attendance there, and I'll put the attendance link here. But now that the semester is clearly started and we're going, I am dropping students who are not checking in. I am dropping students that are not taking the time to check in and be a part of the class. So make sure that you check in on those attendance links. If you have any issues with the attendance, please let me know, okay? Because I don't want to drop somebody who's active in the class, but they're just not clicking the link. So by all means, let me know. When we left off, we were talking about Russia, and we need to keep talking about Russia. We need to complete Russia. Russia is a very unique state within the family of European nations. Russia is in many ways an outlier. There's unique aspects of Russia that must be understood to understand how Europe is going to move into the modern age. And so why don't we go ahead and keep going? When we left off, Ivan IV had become Tsar. He was actually the first Russian monarch to take the term Tsar. And Tsar simply means Caesar. It is a Russian version of emperor, if you will. This image of him is actually a little bit later. This was not painted during his lifetime, but you get the idea. Ivan was actually known for being a reasonably capable leader in the early years, but later on he had some sort of mental breakdown. Nobody really knows what it was, and he turned into just an absolutely horrible human being, murdering and destroying villages and having fits of paranoia where he would lash out. He was eventually assassinated in 1584 after he had just gone too far off the deep end and has since been termed Ivan the Terrible. Well, moving forward, in 1598, about 14 years after Ivan, the Tsar died with no heir. The family was effectively extinct, and there was nobody to legitimately take the throne. And for 15 years, Russia sort of fell apart, and there was a series of civil wars as powerful nobility were fighting each other over control. The church got heavily involved as well. The church wanted there to be a stable Russian leader, of course. And this is an era known as the Time of Troubles. This is an era known as the Time of Troubles, about a 15-year period where things were pretty chaotic. Finally, in 1613, the nobility met in a body that they called the Duma, which is simply the Russian word for parliament. But at this time, it was just a cluster of noblemen. And to end the fighting, they chose a new Tsar. They simply selected a Tsar. Now, this was a far more contentious process than I'm letting on. Not everybody was entirely on board with this idea or who they chose, but it ended up working. Now, I want you to think about what monarchs are looking for. I want you to think about what nobility are looking for. Remember, the nobility want a weak monarch, and the monarch wants weak nobility. Y'all know that, right? Well, in that context, the nobility of Russia chose someone who was weak. They chose 16-year-old Michael Romanov. They chose 16-year-old Michael Romanov. He was a minor nobleman. He had very little wealth. Obviously, he's still basically a child. The church endorsed him. And so the Romanov family would become the royal family of Russia. And Michael Romanov never did much significant after that. Again, he was relatively ineffective as Russia's emperor, but of course he has the title, doesn't he? And what that means is that his descendants will also take the throne. And just like in France, this is the age of absolutism, and we see over a couple of generations, the monarch once again becoming exceptionally powerful. And that leads us to Peter the First. That leads us to Peter the First, also known as Peter the Great. He took the throne unofficially in 1682, officially in 1689, because he had a disabled older brother. That's not really relevant here. And Peter was unlike any czar that had come before him. By now, the Romanov family is firmly in charge. Peter will be an absolute monarch. He will certainly act as one. And Peter was very much determined to modernize Russia and pull Russia into the family of great European powers. He was very interested in modernizing Russia and pulling Russia into the family of great European powers. You see, Russia is an outlier in the sense, and this is one of the many ways it's an outlier, in the sense that it sits on the bridge between Europe and Asia. It's not entirely European in the way its institutions are structured, certainly not at the time of Peter. And an awful lot of Europeans really kind of saw Russia as this foreign, exotic place. They're not really like us. Their language is weird and their culture is weird. And yeah, they're Christians, but they're Eastern Christians. They're sort of like us, but not really. They're not German, they're not French, they're not Italian, they're not English. They're kind of odd. And Peter was not going to tolerate that. Yeah, question?
I was just asking, what's the significance of Michael? Was he just the start of the
He was the start of the Romanov dynasty, that's exactly right. And the question was, what's Michael's significance? Michael Romanov never had anything really significant after the fact that he became Tsar. Okay. There's nothing about him that we really need to get into. Weak, poor, but he gets to be the czar. But his descendants, of course, very quickly changed that scenario. Well, Peter saw the West. Peter saw Europe as Russia's future. He did not want to look at the East and the Asian cultures. He wanted to look to the West, to the European cultures as Russia's future. And he put his entire rule as czar into westernizing his country. Now, there's the little ways in which he did it, but there's also the more significant ways that he did it. Let's start with the little ways. Peter demanded that the Russian people begin adopting European customs and European styles. He demanded that the Russian people adopt European customs and European styles. He wanted the Russian people to dress European, to act European, to look European. One simple way to look at this is to look at Peter. Here is one of his portraits as czar. We could take another portrait. What we have here is a very European-looking man. He is clean-shaven except for a mustache. That was obviously the style at the time. Peter is wearing a waistcoat, which is, again, popular in Europe. The clothing, the style, clearly looks Western. Now, I want you to compare that with our old friend Ivan, and you can kind of see a difference. Now, why would a traditional pre-Peter the Great Russian man have a big, long, burly beard and, a big, gigantic fur coat, the big old fur hat? What's going on there? It's cold. That's exactly right. It is very, very cold in Russia, particularly in the winter. And so, of course, it makes sense that men would dress like this. Well, To Peter, this looked primitive. This looked barbaric. This is the kind of thing people make fun of. You know, we laugh at guys that look like this. And so Peter wasn't going to do that. He was going to look stylish, and he demanded that the nobility and the upper classes in Russia look proper, if you will. Peter would not let the men of Russia grow those big, long Uncle Jesse beards. He actually put a tax on them. So if you're going to grow one of those beards, you actually got to pay for it. And he had men stationed outside the major cities with, knives and scissors that would cut the beards and also cut off the coats to make them waistcoats if the men entering had not paid the tax on it. But the whole point there was to get the men to dress more fashionably. And of course, he demanded that of the nobility as well. The rumors have it that Peter himself forcibly sort of beat up and shaved a number of the noblemen who didn't want to play along. He was a big, strong guy himself, and so he kind of showed them what's what. Peter would not allow the Russian language to be spoken at his own court. Now, that might sound a little silly, right? They're Russian people. Why can't they speak Russian? Well, to Peter, Russian was not a Western language. If the people of Russia are going to be cultured, if the people of Russia are going to be Westernized, they needed to speak a more European language, a Latin-based language. And so what language do you think was spoken at the French court? French. That's exactly right. French would be spoken at Peter's court. And French being spoken at the Russian court would be a tradition all the way up until the end of the monarchy. You don't speak Russian at the Russian court, you speak French at the Russian court. And you better believe, again, the big Russian nobility who didn't give a flip about Western Europe, they did not like this at all. They howled about it, and Peter did not care. Peter brought in men to teach dancing. Men brought in artists to paint the palaces and decorate the cities. Peter invited scholars to come to Russia to establish and work at universities to teach things like architecture and design, to teach mathematics, modern science, all of the things that the Europeans themselves, the scientific revolution is going on, all of this to teach the Russian people how to be Western. And Peter was himself willing to put his money where his mouth was. Peter actually traveled throughout Europe for several years, and he did it actually incognito. He didn't actually travel as the Tsar. He traveled as a common laborer. We'll get into this in a minute, because he himself wanted to learn the European way of life. Peter once said, I am going to drag Russia into the West if I have to do it with the people kicking and screaming. Peter understood one fact, Peter understood one fact that geographers have pointed out for a very long time. Geographers have one phrase that sums up their profession. Geography is everything. And if you talk to geographers, they will say that one fact. Geography is everything. And Peter understood that Russia was the way it was because of Russia's unique geography. You see, Russia has an enormous amount of land and natural resources, more than any other nation in the world. But Russia is sorely lacking, woefully inadequate in one area. And who can tell me what that is? Can anybody see what's missing in Russia? Goodness knows they've got more than enough land and everything that comes on it. And of course, the population is much bigger than the rest of Europe. But there's one thing Russia doesn't have that other European states do. Anybody know? Naval access. Russia does not have good access to warm water ports. There's no warm water coastline in Russia that will enable Russia to build an effective navy. You see, if we look at the rest of Europe, we'd have to go back. Let's go back a little bit. If we look at the rest of Europe, we see states like Portugal, Spain, France, and England, they've got the Atlantic Ocean right on their front porch. It is not a coincidence that the age of exploration was spearheaded by Western European states, right? The Portuguese, Henry the Navigator. We got the Atlantic right there. We're perfect. Let's send the boats out, right? Russia simply doesn't have that. Russia simply doesn't have that. As a matter of fact, at the time of Peter the Great, Russia didn't have any access to the Atlantic without having to go through the Black Sea. And Peter understood that it is this lack of naval access that has kept Russia from really playing the European game. How is Russia going to go out and colonize anything if Russia can't put boats in the water? Are you following me? How is Russia going to trade? The East India Company, right? The United East India Company and the British East India Company, both of those existed because Britain and the Netherlands could access the Atlantic, right? Very easily sail their boats out. Peter understood that naval power, both for trade, for military, naval power makes a nation great. Naval power makes a nation great. And this is a theory that has never really gone away. Yes?
So why couldn't they just build a port right there by the Arctic Ocean?
And that's a great, yes, they've got thousands of miles of coastline. The problem is that's iced in most of the year. And now they actually do. There's a place way up here, I guess you can't see it here. There's a place up in the Barents Sea called Archangel, and it's actually a Russian port. But it's, again, it's only open for a few months out of the year, so you can't really have an effective navy going in and out or effective trade going in and out. I mean, the Dutch are trading year-round. And so what he needed was a port open to the Atlantic, and that was going to have to be on the Baltic. It is not perfect. It is not perfect, but if he could get some land right there, and you see the purple, if he can get his boats around Denmark, he can get boats into the Atlantic. It is far more limited than what, say, France or Spain or England would have, but it would still open the door to Russia having a navy. Peter was obsessed with navies and naval technology. He was absolutely obsessed with it. When he traveled, I mentioned earlier, when he traveled, he actually spent 7 years as a shipyard worker. He wanted to learn how to build boats, and so he worked in naval yards. And I'm not kidding. He did not announce himself as the czar or anything like that. He traveled as a common laborer, worked on boats, had his crew with him. As I understand it, he had to go from place to place because sooner or later people would figure it out, and then that would, of course, cause a big deal. So he and his guys would go from place to place. At one point, they showed up in England unannounced, as I understand. And when the King of England found out the czar had shown up, of course, immediately he sort of hastily puts together an entourage and gives them a nice house to stay in, which they proceeded to destroy. One of the accounts of that, again, I'm not kidding, he showed up in England completely unannounced, but of course it's a big deal. Apparently the Russians had not seen wheelbarrows before, and so they got drunk and were wheeling each other around in wheelbarrows, and they ended up knocking holes in the wall and all of that. Anyway, he was just obsessed with naval technology. He was obsessed with naval technology. So in order to build a navy, he was going to have that land. And so he fought several wars in order to get it, and you see it here on this map, that little purple area, so that he would have a Russian port on the Baltic, which he would call his window to the west. And of course, once he got that land, Peter demanded that a new city be built to be a new Russian capital. A modern city, a European city, a city that could rival Paris or Berlin or Vienna. A city that reflected a modern Russia that is now a great European power. And of course, what would be the name of his new capital? It's on the map. St. Petersburg. The name of his capital would be St. Petersburg, and he demanded that St. Petersburg be built in his lifetime. And so thousands and thousands of Russians were pressed into service to build this new city. And it is gorgeous, and it is European, and it looks nothing like what you would have found in the heart of Russia. It does not look like Moscow. It does not look like Kiev. Of course, the new palace right on the water would be called the Winter Palace. And if you didn't know any better, what could this be? What do you think this is sort of designed after? That's actually a different palace. That's a St. Catherine Palace. Here's another palace. They have lots of palaces, but here's another one. But let's look at the inside. Here's one of the grand rooms in the Winter Palace. At least I think it is. Here's another one, right? This could be Versailles, right? This could be modeled after something the Habsburgs would build, like the Schönbrunn Palace in Vienna. This is European in every way. And the whole point was the Russian palaces are going to rival anything that you will find in Europe. And I think they certainly pulled it off. Go back to this. Now, when Peter took the throne, this is what Russia looks like. It's sort of that brown section over there that says Muscovy. That's Europe in 1700, and you'll see Russia doesn't have Baltic access. It's that corner over here that we're looking at, the Gulf of Finland. Russia doesn't have that land. In 1725, when Peter dies, this is a little bit later, but you will see Russia now has Atlantic access. Now let's go back and look at those pictures of Peter. You didn't know to look for it before, so I'm going to show you something. Let's start with this one. Okay. Here is a picture of young Peter the Great. He's wearing armor, much like we would have seen a Bourbon, right? Much like we would have seen Louis XIV wear. What's in the background? That's a ship in the background, right? He is announcing to the world as a young man, Russia will become a naval power. He is announcing to the world as a young man. Now let's fast forward and look at Peter a little bit older. What's behind him? That's water behind him. What is he resting his hand on with the sword? No, the other hand, the one with the sword. That's a naval cannon, right? Holding a sword, resting his hand on a naval cannon. What message do you think he's sending? We got a navy now. Russia is a military power on the water. And of course, what is his other arm resting on? What's his left arm resting on? It's a map of Western Europe. See? So he is using this picture, dressed as a European king, using this picture to announce to the world, Russia is a Western European power. We have a navy. We are in the club. This is a picture that has a very real propaganda element to it. And actually, that little medallion thing around his neck with the crown, you can see that there, indicates that he is a monarch, and the blue sash is the sign of a monarch, just in case you're wondering. And he is looking European. He is not looking, all, weird and burly like Ivan IV. When people think of the Tsar, Peter doesn't want this image to come to mind. Peter wants this image to come to mind. Now, you can understand why he would be referred to as Peter the Great. That being said, the extent to which he modernized Russia, the extent to which he actually accomplished his goal, is certainly subject to debate. Nobody would argue that St. Petersburg was a remarkable accomplishment. Yes, it is designed in every way that we would label European, the Winter Palace, and he brought in university instructors and scholars and scientists, and he definitely sort of westernized Russia in that sense. However, there's a couple of factors here that we need to keep in mind. First of all, the cost for doing this was incredibly high. Thousands and thousands and thousands were killed in the wars that he fought to conquer this land. Was that really worth it? And of course, thousands of more young men were killed simply being worked to death to build St. Petersburg. He was merciless. This city will be built, and it will be built quickly. And that means lots and lots of forced labor, which Russia is certainly not new to. That's going to happen later on as well. Also, once you go outside of the Russian cities, particularly St. Petersburg, once you go back into the countryside, you're back in Russia again. Russia remained a poor, I don't want to say backwards, but certainly underdeveloped nation when compared to its European counterparts. On average, per capita, the Russian people were far less literate, far less formally educated than those in Central and Western Europe. The Russian government remained far more autocratic and repressive, with far fewer civil liberties or far fewer respect for the well-being of the people. And this would continue long after the rest of Europe had sort of entered the Enlightenment and a more modern age. The average Russian was less well off economically. The Russians were poor. The per capita income and the per capita wealth of the average Russian was far lower than what you would find in the rest of Europe. The Russian government was, of course, very corrupt. The Russian government was very corrupt. There's bribery and cronyism and all types of behavior that would be considered intolerable in other parts of the developed world was just extremely commonplace in Russia. Bribery and corruption was so common in Russia, it was the only way anything ever got done. And so the question is, was Russia really modernized or not? It's really kind of hard to say, right? That's kind of up to you to decide. Russia has always been described as being one or two steps behind the rest of the developed world. And again, a lot of scholars credit this problem with lack of naval access. The inability to trade and interact with the rest of the world on the water has always been a real hindrance for Russia. Even up to the modern era, this has been a problem. Now, what we will acknowledge is that after Peter the Great, Russia is most definitely a great European power. You see, the other nations of Europe, the German states, the Habsburgs, the French, etc., they don't respect Russia so much as they fear Russia. Why would they be afraid of Russia? It is a constant theme that we will see all the way up to the present day. Russia isn't respected so much as Russia is feared. Why? Just its sheer size. Bingo. Exactly. Russia is so much bigger. There is just so much more of it that if Russia ever does get its act together, if Russia ever does modernize, Russia could just steamroll over the rest of Europe and dominate the continent, if not much more than that. The population is just so much bigger, you don't have to have a modern army when you've got a bazillion peasants with sticks, right? And a czar that's more than happy to, slaughter them by the thousands in order to win a war, right? You don't have to have modern infrastructure when you've got all the natural resources you could ever possibly use. The food production in Russia alone is just staggering, or at least the capacity for it. And so the nations of Europe understand Russia kind of isn't really a threat because Russia is so underdeveloped. But man, what might happen if Russia did get a modern army, if Russia really did get modern infrastructure, if Russia really did catch up, so to speak? And the real irony of that, as the Russians have pointed out for a long time, is that Russia hasn't really been an aggressive power to begin with. Russia has never really shown a desire to invade and conquer Europe, Cold War notwithstanding. Russia has been victimized by Western Europe more than Russia has been the aggressor. And we'll of course, get into that as we get into the 20th century. That was a big part of the post-World War II settlement as the Nazis are being defeated and Stalin, who was the Soviet leader, was meeting with Churchill and Roosevelt. Stalin was first to point out to all of them, yes, Russia's going to control a lot of Eastern Europe because y'all are the ones that are always invading us. He said, look, we're the ones that keep getting invaded. We're not hurting anybody. So anyway, it's a little more complex, but Russia is feared. Russia is feared, but it's always a step or two behind. Well, with that, let's draw a big line in our notes because we're starting a brand new topic. I want to talk about the scientific revolution. So we are jumping to a whole new place. We are jumping to a whole new place. By the 17th century, the medieval view of the cosmos, sort of the Dark Ages view of existence, was beginning to break down. It was beginning to disintegrate. And I'm going to spell medieval for you. That simply means the Middle Ages. During the Middle Ages, of course, educated thinkers who were almost always clergy argued, of course, that the earth was the center of the universe and all that existed was part of God's plan. All that existed was part of God's plan. Now, there were very legitimate attempts at what we would call science. These were not people that were completely ignorant or unwilling to learn scientific topics. But there was no mechanism in place to rationally understand the world on human terms. There was no mechanism in place to rationally understand the world on human terms. And anything that was perceived as going against literal biblical scripture was frowned upon. Anything that was seen as perhaps questioning biblical scripture was not really embraced. Now, again, these people were not as completely clueless as we would think, but you get the idea. What begins to happen about the year 1600 is that structure starts to break down. Real science as we know it starts to emerge. Real thinkers start to come forward wanting to understand the world on human terms, wanting to understand the world in ways that we would consider logical. One of the early men who pioneered this way of thinking is the fellow you see right here, Francis Bacon. Bacon developed what we call the scientific method, and it is still very much in place today. Bacon developed the scientific method. The scientific method is a method of seeking knowledge through inductive principles. A method of seeking knowledge through inductive principles. The scientific method uses experimentation and observation to develop generalizations. It uses experimentation and observation to develop generalizations. And this is the kind of thing that we studied in middle school. One of the early lessons in your middle school science class was discussing the scientific method, and so let's walk through it real quick. If you want to learn something scientific, if you want to learn a scientific principle, you first have to figure out what you want to know, and you formulate a what? You formulate a hypothesis, exactly. You formulate a hypothesis. And what is a hypothesis in common terms? What is a hypothesis? An educated guess. I kind of think this is how something works. It's an educated guess. That's all it is. Maybe it's right, maybe it's wrong. Let's figure it out. So then, once you have your hypothesis, what do you do with it? You test it. You develop neutral, objective testing to see if this hypothesis is correct. If you cannot test your hypothesis, then you don't have a hypothesis. If your hypothesis is that aliens are actually coming down from Earth and beaming people aboard their spaceships, you got to come up with a test for that. Can you come up with a test for aliens beaming us up? No, you can't. So you can't really hypothesize something without there being an objective test that can go along with it. And if somebody just happens to disappear, your hypothesis can't be they were beamed up by aliens, right? Just because something exists doesn't mean you get to make up some wacky reason for it if there is no real way to test a hypothesis based on it. Well, let's say you test your hypothesis, and it looks like you're correct. It looks like your objective, neutral test is confirming what your hypothesis was. You don't have a hypothesis anymore. What do you have? You have a theory. You have a theory. The control is actually part of the testing, right? You know, you have the control group and the testing group, and then some tests do that. What type of testing involves having a control group and not? What's probably the best example? We're doing it right now. What's that? Vaccines, yeah, medical testing, vaccines, right? So what we do, like with a coronavirus vaccine, the hypothesis is I've got this vaccine that I think will work. And so what we do is we have one group of people that we give the vaccine to, we have another group of people that we don't give the vaccine to, and we see what happens, right? And if the vaccinated people don't get the virus, but the unvaccinated people do, then we have a theory that that virus works. So, once we have our theory, and it appears to be correct, we got to do two things. Number one, we have to publish it. You publish your theory, and then, of course, you do more testing. You publish and test. So others can see if your test can be repeated. Others can try to find holes in it. Others can try to sort out their own versions. Your test is not valid unless it is repeatable. Now, after lots of publishing, lots of testing, lots of scrutiny by plenty of other people who are trying to figure out what might be wrong with your theory, if everybody finally agrees, then we have a law. Then we have what we could consider truth or knowledge. And this scientific method is every bit as in place today as it was when Bacon came up with it in the 17th century. Once Bacon does this and others begin to agree, philosophy starts to adapt to the idea that we are supposed to learn the world around us, that we are supposed to understand the world on human terms, that progress as a people, progress as a civilization, progress as a species depends on us embracing more knowledge. That's what sort of separates us from the uncivilized or the non-human. There was a philosopher named Descartes. And you can be certain this is not a philosophy class. But Descartes argued that there is a separation between your physical self and the way you think, your personality, your knowledge, your consciousness. What you are as a person isn't necessarily your flesh and bones, it's also your thinking. That's what really makes you you. And your mind is constantly craving knowledge. Your mind is constantly craving knowledge. Descartes' famous line that everyone has heard, I think, therefore I am. I think, therefore I am, right? You are a person because of the way you think, because you understand that you are a person. And so Descartes would argue, and Bacon would agree, that moving humanity forward requires learning objective truth, studying the world. How does it really work? How does the human body work? What are all these substances that make up the earth? What's going on up in the sky? Knowledge, real knowledge. This going to make some people uncomfortable? Well, people that suddenly aren't speaking the truth anymore, sure. Or people that are threatened by new ideas, certainly. The best way to understand the scientific revolution is perhaps to take a look at astronomy. One way to understand the scientific revolution is to take a look at astronomy. Now, I am talking about astronomy, not astrology. Astrology is the nonsense of you being a Libra or a Pisces or a Capricorn and, you read your horoscope. That's astrology, and obviously that's not scientific. I'm talking about astronomy. I'm talking about astronomy. Well, the scientific revolution is going to take astronomy by storm. Since antiquity, humans had been looking up at the sky and wondering what's up there. And of course, I hope you've already figured out that an awful lot of this scientific revolution is really just a rediscovery of what the Greeks and the Romans had done hundreds of years earlier. The Greeks were also scientists. That's what Greek philosophy was. It was science. Well, humans have been looking up at the sky and wondering what's going on. First and foremost, there was never a debate that the earth was round. For the most part, everybody understood that the earth was round. This idea that Columbus was trying to prove the earth was round and not flat, that's all nonsense. Everybody's known that the earth was round. How round it is, how big around it is, the other aspects of it being a sphere, perhaps not quite understood, at least not in Europe. Well, along comes a man by the name of Copernicus, Nicholas Copernicus. He was Polish, and you'll notice he's coming a little bit earlier than Bacon, but he is the first modern astronomer. He is the first modern astronomer. The one thing about the Poles, the one thing about Poland, is they're good at math. Polish people have always prided themselves at their ability to do math, and that's all the way up to the present day. So a lot of great scientists come out of Poland if the science is math related. And Copernicus is certainly part of this tradition. Copernicus had studied the ancient Greek texts. He was well versed in the classics. And he figured out by reading what these Greeks had to say that they not only knew that the earth was round, but they knew that the earth is going around the sun. When you look up in the sky, it's not the sun going around the earth, it's the earth going around the sun. Now, he didn't know this, but other people around the world had figured this out as well. The Mesoamerican people, for example, the Maya and the Inca also knew that the earth is actually the one that's going around the sun, not the other way around. But anyway, at this time, the accepted model of how the universe is structured puts the earth at the center and everything that we see going around it. And this is known as the Ptolemaic model. This is known as the Ptolemaic model. And if we look here on this, we can kind of see a Ptolemaic structure. Right here, that mess in the middle, that's Earth, right? That's Earth and the atmosphere. And then we have Luna, which is what? The moon, then Mercury, then Venus. Solus, that's the sun. Martis is Mars. Iotis, or Iovis, is Jupiter, and then Saturn. And then everything after that. That is the academic understanding of how the universe is structured prior to Copernicus. Here is another version of it. You can see we have the Earth and then, this isn't the structure of it. This is the new model. This is the new model. This is Copernicus's model. And we can see in this one, the sun is at the middle. And then we have Mercury, then we have Venus, then we have Terra. And of course, what is Terra? That's Earth, right? And then the moon is going around it. Then Mars, then Jupiter, then Saturn, then Sphera Stellar Fixar, fixed stars. This is what I wanted to show you. This one here is a fancier version of Copernicus's version. We have the sun, and then Mercury, Venus, then you can see the Earth, and then the orb of Mars, the orb of Jupiter, the orb of Saturn, and then the orb of stars fixed indefinitely. There you go. So simply put, Copernicus starts arguing it is the sun at the center of the universe. The planets are going around it. Now, Copernicus was not 100% correct, was he? Is the sun the center of the universe? Yes or no? I hope everyone in here knows that the sun is not the center of the universe, right? The sun is just one star in the Milky Way galaxy, right? It's our little center of the universe in our solar system, but you get the idea. But Copernicus is on the right track, isn't he? He's got the right idea. Not a perfect understanding, but there we go. Now, Copernicus will publish this in 1543, and immediately, along with other information, other astronomers start looking at it, and they start doing the math, and they start paying closer attention, and all of a sudden we have a debate on our hands, with some astronomers not believing him, some astronomers believing that he is correct. Over time, however, the proof is simply indisputable. Over time, academics can simply no longer deny the fact that Copernicus was right. The math adds up. The numbers don't lie. About 50 years later, a man by the name of Johann Kepler. Now, with a name like Johann, what is his ethnicity? I'm sorry? No, he's German. Johann is just a German version of Jonathan. Johann Kepler doesn't just prove beyond a doubt that Copernicus was correct using his own research. Kepler also demonstrates that the planets do not go around the sun in perfect circles. The orbits of the planets are more ovoid than circular. There's times when the Earth is closer, there's times when the Earth is farther away. Also, the planets are not moving at the same speed. They're going at different speeds. So he's taking this knowledge to another level. And of course, by the time of Kepler, certainly after him, there's not much debate anymore by astronomers. They know what the truth is. Along comes the next astronomer, and the most important of these from this era, Galileo. Now, with a name like Galileo Galilei, what is his ethnicity? With a name like that, where does he obviously live? I'm sorry? A little louder? Yes, he was Italian. He was Italian. Copernicus was Polish. Kepler is German. Galileo is Italian. Now, of course, what is this telling us also when we know we've got different men from different countries that are studying the same thing? What's happening? What do we get out of that? Knowledge is being shared, right? Information is crossing borders. The world is becoming more interconnected as I can publish a paper in one country and you can read it in another. And we'll get into what that's all about later. But understand, this is a multi-ethnic study here. Academics don't care what country they live in. They work together as a common group. Well, Galileo was a highly, highly intelligent man, to say the least. He was brilliant at math, but he actually figured out how to magnify the planets. He developed, by contacting glass makers and lens makers, he developed really the first telescopes. Obviously very primitive by today's standards, but high technology at the time. And what really mattered was the ability to fit multiple lenses in the same tube and focus them properly. And it took a high degree of precision to get it right. So technology comes into play here. And he was so proud of his telescope. Here you have him posing with his telescope. What Galileo does is he is able to demonstrate that mathematic truths exist for every element of the universe. We can not only understand how the planets are moving, we can predict where they're going to move because it's all math. That's all it is. And that once you understand the formulas, you can understand the cosmos. We know where the Earth will be, where the moon will be, where Mars will be, hundreds, thousands of years into the future, as well as hundreds and thousands of years into the past, because of the math involved. Because of the math involved. Galileo was able to demonstrate that there really isn't a distinction between down here and up there. We are, in fact, in space right now. Y'all know that, right? Now, if we're in space right now, of course, why are we breathing air and why are we stuck to the Earth? Well, that's atmosphere and gravity, right? But the truth is, if you go up, eventually you leave gravity, you leave the atmosphere. There is no some sort of barrier between down here and what they would call the heavens. And this was troubling. This was troubling to a lot of people. Galileo was able to demonstrate that celestial bodies, the Earth, the moon, Mars, whatever, are not perfect. They are not uniform. The Earth is basically just a big rock. That's all it is. The Earth is a big rock. And what is the moon? It's a big rock. What's Mars? It's a big rock. Y'all are getting the idea, right? Now, of course, Galileo isn't entirely correct. He's got the right idea, but the Earth actually isn't a big rock. The Earth is a big blob of molten iron with a little bit of rock floating on top. Jupiter is a big ball of gas, right? But you get the idea. They're all just a bunch of big rocks. Nothing special about them, nothing perfect about them. They're all sort of floating in space, orbiting the sun based on mathematic principles that we still don't quite understand. Now, Galileo's teachings are so well written and so well published and so well understood that by the time he is in his prime, the entire academic nature of Europe is being rewritten. This is no longer being taught as controversial or one of many ideas. The idea of the Earth going around the sun and Copernicus and Kepler, this astronomy is now being taught as truth. And hundreds of Europeans, thousands of Europeans, every year it seems like more and more are getting a better understanding of this, asking more questions, learning more knowledge. It is often believed that the church was very, very much against this. That's not entirely true. The truth is it's a lot more complicated than that. The church was never anti-science. Galileo was a devout Christian. So was Copernicus. I'm assuming Kepler was. For most of this time, the church has never really stood in the way of astronomy. None of these men are openly criticizing the church in any notable way. The idea that the church is against science is really quite a stretch. But Galileo hacked off the Pope. Galileo did a couple of things that personally insulted the Pope, or at least the Pope at the time found it insulting. And one thing you don't do if you're living in 17th century Italy is insult the Pope. And so what happened was, really not because of his science, but because the Pope wanted to make a statement of who's in charge, the church concluded by the time that Galileo had really more or less ended his career, all this happened kind of toward the end, that Galileo had crossed too many lines, that Galileo had come to openly engage in heretical behavior, questioning God's plan for the universe, questioning the biblical story of creation, etc., etc. And you don't do that. That is heresy at this time. So, and again, this was more of a personal issue than it was about the science. Galileo was actually put on trial for heresy At this time, he was quite old. He had basically quit doing any work anyway because he couldn't see very well. Now, what we have to understand about heresy trials is that this was a way of the church enforcing its monopoly on the faith and belief of the people. And we've already talked about religious conflicts. I think we went into that a little earlier. And if you are put on trial for heresy, you are already guilty. You don't get found not guilty in a heresy trial. You've really got two options. You can confess that you have engaged in heretical behavior, in which case you can do penance and be forgiven, or you can insist on your innocence, and they're going to find very brutal and unique ways to make you confess. You know, the notorious Spanish Inquisition, which tortured and murdered people, is a good example of that. And so Galileo understood what the deal was. And so, under this kind of pressure, Galileo confessed to heresy and recanted all of his work. Realizing they're going to kill me if I don't, he went ahead and said, fine, you win, I'm wrong, everything I've written is wrong, etc., etc. Now, everybody knew that this was just a publicity stunt. Everybody knew that's not what he really believed, and nobody took any of that seriously. The genie was out of the bottle. His works were being studied all over Europe, and that was not going to change as a result of this. Galileo then quietly retired with his head attached to his shoulders. And of course, privately, Galileo always recognized, always admitted, look, I didn't really recant. It's all a game. And there we have it. But unfortunately, this created the long-standing myth that the church hates science. This created the long-standing myth that it's not possible to be a person of faith and a person of science at the same time, and that the church is backwards and all of that. And that's not entirely true. Now, there certainly are elements of that have bled over to the present day, but you get the idea. The truth of the matter is the church never really got in the way of anything scientific. Up until the modern era, there's, these issues of, church people hating evolution and all of that, but that's just kind of silly. Anyway, let's now move forward to the greatest scientist, certainly from the scientific revolution. Some would argue the greatest scientist of all time, our friend Isaac Newton. Everybody in here has heard of him. And of course, what's Isaac Newton known for? When we think of Isaac Newton, what do we think? Gravity, right? Isaac Newton discovered gravity, or the law of gravity, and of course, what's the old tradition say? How did he start thinking about gravity? What did he observe? An apple falling from a tree, right? Or an apple fell on his head. Actually, there's certain truth to that. He did observe an apple falling, which helped him think about how gravity really worked. And the tree is still alive. You can actually see Isaac Newton's apple tree today, as I understand. But anyway, Isaac Newton was vastly more than a man who discovered gravity. Newsflash, folks, gravity is something that Isaac Newton didn't need to discover, right? Isaac Newton is the father of physics. Isaac Newton is the father of physics. Isaac Newton was English. Again, we're jumping nationalities here. He came from a comfortable but not rich family, but he was given a good education as a child. Squarely in the middle class, which we're going to see a lot of these important thinkers come from the middle classes. And he was, in every sense of the word, a super freak genius. Just crazy intelligent. His immense brain power was well beyond us mere mortals. He was one of those rare people whose intelligence is simply off the charts. And he used that powerful brain of his as much as he could throughout his life. Isaac Newton studied and mastered pretty much every scientific field that existed at the time. He had a high degree of understanding of it all. Astronomy, biology, chemistry, their versions of it, of course. He invented fields of mathematics that simply did not exist. I believe, what was it, calculus, I think, is something that, so you can thank him for that. If I'm not mistaken, it was calculus that he actually created. It didn't exist before him. He was just obsessed with learning as much as he could, with figuring out as much as he could. And he had a very diverse life. He had different jobs and did different things. I'm summarizing his life in a very general sense. He was particularly interested in optics. He was, of course, the man that figured out that light travels in waves, which starts with the understanding that light actually travels, that light doesn't just appear instantly. Light actually moves. It moves really, really fast, but it still moves. And then he figured out that it travels in waves. And of course, these waves are what is responsible for different colors. Different wavelengths of light enable us to see different colors. And of course, from that, he is able to sort out the fact that most of the light out there we cannot see. Our eyes have evolved to see certain wavelengths of light, but most wavelengths of light that exist, our eyes cannot pick up. The visible spectrum of light is tiny compared to the entire spectrum of light that exists. One man told me, I believe this is true, that if you took the entire wavelength of light, the entire spectrum, and you started at Los Angeles and you ended it at New York, the part that we could see would be the width of a dime. That is how much light is out there that our eyes are simply not able to pick up. Light is how microwave ovens work. Who in here knew that? Anyone? Light is how microwave ovens work. That's why it's called a microwave. Itty bitty microwaves of light. And what those microwaves do, there's a very specific wavelength that when it hits water, it causes water molecules to vibrate. And when water molecules vibrate, they produce friction. And what does friction produce? Heat. And so when you put something in your microwave, what's happening is that wavelength of light that is created by a device known as the magnetron causes those water molecules to vibrate, and it heats up your burrito. Why is the inside permafrost and the outside, Chernobyl meltdown hot? Well, that's because the light is not penetrating to the inside of your food. And so the outside is getting vibrated by the light, but the inside is remaining shielded from the light. So the way you microwave something is you got to make sure there's a hole in the middle. Also, you use power levels, right? Now, the power level on your microwave doesn't actually change the light. All it does is change the number of seconds that it's going. So if you put it on power level 5, you'll hear the magnetron kick on for 5 seconds, then it'll kick off for 5 seconds, then it'll kick on. Y'all can hear it, So next time you do your microwave, set it on a power level, and you'll hear the magnetron kicking on and off in second intervals based on what you did. Now, why is your microwave not microwaving you? If it's going to make water molecules vibrate, why is the only thing getting cooked on the inside? That's it. There's a shield. The inside of the microwave is actually shielded from that light, and the window has that little screen on it. You'll notice the window is not perfectly clear. There's a screen. That screen blocks the light from getting out. So if you take that screen off, or if you somehow figure out how to open the door and start it, you're going to get microwaved along with the food. So I don't think you should do that. And, it's probably a good idea to step back when it's going anyway, right? Don't be like on the glass, staring in, waiting for that burrito to cook. It'll be fine. I knew a guy that was so incredibly lazy. He set his microwave for like 20 hours, and so he would just hit start and stop, right? He didn't have to press the buttons. And when he put something in, he would stare at the glass, and I'm like, dude, you're nuking your eyeballs, you know that. And he's like, I don't care, I'm hungry. Anyway, light travels in waves. Light travels in waves. He wrote a lot of stuff, but Newton's magnum opus, his number one work, was Principia Mathematica, a massive work that discusses all ranges of physics. Groundbreaking. This had all new information, vastly more advanced than anything that had come before. Vastly more advanced than anything had come before. And he talks about how light moves and all kinds of cool stuff. And of course, it is in this that he outlines his theory of universal gravitation. He is not talking about how gravity exists. Everybody knows gravity exists. What he's doing is he's talking about what gravity actually is. And of course, he points out that gravity is a universal glue that holds all of the objects in the universe together. The Earth is in orbit around the sun because the sun's gravity is acting on the Earth. And of course, we are stuck to the Earth because of the Earth's gravity on us. And every body in motion affects every other body in motion through gravity. He also is able to demonstrate that once in motion, a body does not stop. Finish it. Once in motion, a body will not stop unless force is acted upon it. Exactly. If I'm in outer space and I chuck a baseball, that baseball will go on forever unless something else acts on it, i.e. gravity or something else. Newton discusses inertia, acceleration. And for every action there is an equal and opposite reaction. That is exactly right. For every action there is an equal and opposite reaction. Now, Newton takes a giant leap forward in our understanding of physics and our understanding of optics and our understanding of gravity, and you're starting to figure out maybe all this stuff is tied together, correct? Who will be the next? Well, we'll answer that in a second. Newtonian physics ran into a very big problem. Newtonian physics ran into a very big problem. Now, stop writing. It's just interesting to think about. You see, once we figured out that light moves, later on, physicists were able to figure out exactly how fast light moves. And of course, that nothing moves faster than light, and we'll explain why here in a minute. How fast does light move? The speed of light, yes, light definitely moves with the speed of light. 186,000 miles per second. Light moves at 186,000 miles per second. That's fast. Nothing in the universe moves faster, and I'm about to explain to you why. Because you might be thinking to yourself, well, why can't something just move faster than that? Why is this the universal speed limit? Here's why. Something weird was happening that physicists could not figure out. We're going to conduct a little experiment here. Bear with me. Thought experiment. If I'm standing still and I've got a baseball, and let's say I'm a heck of a pitcher, okay? And I pitch that baseball 100 miles an hour, you could measure the speed of the ball. It starts here with me. I throw it 100 miles an hour. You can see that that ball is going 100 miles an hour. Does everyone follow me? Right? Now, just play a little game here. Let's say I'm Evel Knievel and I'm a daredevil, and I am on a train. And let's say the train is already going 100 miles an hour, okay? And now I pitch that ball 100 miles an hour. How fast is the ball going? Well, but how fast is the train going? If the train is going 100 and then I throw the ball 100, how fast is the ball going? 200. Simple math, right? The ball's already going 100 miles an hour because it's with the train, and then if I add another 100 to it, the ball's now going 200. Are y'all following me? Here's where it gets freaky, and nobody could figure this out. If I am standing still and I turn on a flashlight, the light coming out of that flashlight is going 186,000 miles a second. If I am standing on a train and the train is already going really fast, and I turn on that flashlight, you would expect the light to now be going faster, just like the baseball, right? It doesn't. It doesn't matter how fast you are going. Light never travels faster than this. It's like the light slows down to accommodate the train, which is pretty freaky. No matter how fast I go, if I emit light from a flashlight, it's still only going 186,000 miles per second. It's like the light knows to slow itself down to always go the exact same speed. So it's not like a baseball that if you throw it from a moving train, the baseball is now going faster than it was. It's always going the exact same speed. Nobody could figure that out. What's going on here? This doesn't make any sense. Light would obviously have to go faster or slower based on how fast or slow you're going. Does anybody know who finally figured it out? You've heard of him. There's a reason why he's up there with Newton. His first name was Albert. Albert Einstein figured that out. You see, what Newton didn't understand is that there's more than three dimensions. In the world of Newton, there is up, down, sideways, right? The world of Newton is like this room. The universe is in a three-dimensional space. Einstein figured out that the missing ingredient was time. That time is also part of what we factor in when looking at the speed of light and looking at the structure of the universe. That's why he called it space-time. You see, when you are moving, what you're actually doing is going faster in time, and the speed of light is relative to your own perspective. And so if I'm on the train and I shine the flashlight, it's 186,000 miles per second based on my perspective. But if somebody were watching from the ground, I'm actually going through time faster than they are. And it's not my motion, it's my actual changing of time itself. Now, I know it's complicated, but in very simple terms, when you move, you go through time faster than if you're sitting still. And the adjustment in time itself is why light always seems to travel at exactly the same speed. And it's called the theory of what? The theory of relativity. It's the theory of relativity. That's why Einstein is so genius. Einstein was like Newton. He was able to take us to a whole new understanding. What is Einstein's best known theory? Not theory, excuse me, best known formula. E equals mc squared. Now, you might say to yourself, what the heck is this? Y'all have heard E equals mc squared, right? What exactly is E equals mc squared, and why is it so groundbreaking? E is energy, m is mass, c is the speed of light squared. So energy equals mass times the speed of light squared. Every substance, everything that has mass, also contains energy. And how much energy is in everything that contains mass? Well, it's energy that is the speed of light squared, which means it is a heck of a lot of energy. And that's where nuclear physics comes from. Because they're able to figure out that if we can break matter apart, we can release massive amounts of energy. Thank you, Einstein. And on that note, we're done. So we will pick back up later. I hope I confused plenty of people toward the end. Y'all take care. I'll see everybody. And remember, check in, because I am taking attendance, and I will count you absent if you don't.